I would like to give a little summary of the perspective from the Consultative Committee on Radionuclide Metrology on the use of mass spec in our field of radionuclide metrology. Bearing in mind, everybody, please, that mass spec is not the first technique that comes to mind for the average radionuclide, well, none of them are average, of course, but to the usual radionuclide metrologist. So radionuclide metrology is not only in Section 2 of the Consultative Committee on Ionizing Radiation, CCRI, but it is also very heavily involved in another organization called the International Committee on Radionuclide Metrology. The CCRI started its existence as CCEMRI back in 1958. The name was changed to CCRI in 1997. As all the consultative committees of the CIPM, we provide technical support to the BIPM, specifically on their ionizing radiation program and in their radioactivity measurements for the Section 2. We also provide advice to the CIPM regarding ionizing radiation standards. We define our quantities and our units. We plan a lot of comparisons. The radioactivity measurements that are involved, the radionuclide metrology at the BIPM has as its workhorse the International Reference System, the SIR. We'll get a little bit more into that later. CCRI, unlike any of the other consultative committees, is broken up into 3 sections because ionizing radiation involves 3 very different aspects. One is the dosimetry aspects, how much radiation is hitting an object. That is Section 1. Malcolm McEwen from the NRC is the chairman of that section. This particular workshop is very much involved for Section 2 on radionuclide metrology or on radioactivity, and I'm chairman for that. And Section 3 on neutron physics, neutron metrology, the metrology measurement of the neutron is chaired by Andres Simbal from the PTB. Now the ICRM, which was established in 1972, kind of grew out of the CCRI or CCEMRI at the time. CCRI is very much the National Measurement Institutes and designated institutes, the signatories to the CIPM MRA today. But there are so many stakeholders, as many of you know, who are heavily involved, not just in the measurement of radioactivity, but specifically in the metrology of radionuclides. And so the ICRM was established to try to capture those particular interests and that particular expertise. So the ICRM consists of metrologists and others who study and use radioactivity. It is a forum to share information on techniques, applications, relevant data. A lot of basic research and users needing metrology, such as universities and secondary labs, are participants. The whole field of applications for the ICRM start with the production of radionuclides and go all the way to the study of nuclear physics. And as you can see, this the first picture here is from the 2019, the last in-person meeting of the CCRI. A small but elite group of people. The picture you see below is from our 2019 meeting of the ICRM, also the last in-person meeting. Though we have in-person meetings this year for both groups, you can see it's a much larger group of people. So the members of CCRI2, there are 25 members, 24 of them, you see them listed here, 24 of these member institutions are actual metrology laboratories. The ICRM itself is also a member of CCRI2, but since it is not a laboratory organization, but rather we count on them to bring us ideas about needs and activities going out in the larger metrology world. Unlike many of the CCs, length, mass, time, and frequency, CCRI Section 2, for example, a large part, almost half of our members are actually designated institutes. They are not NMIs. And this is because ionizing radiation is often done at a very specialized location in a country. So in ionizing radiation, we have a lot of designated institutes. If you were to look at the list of participants on the CIPM MRA, you would see that there are at least 21 other signatories to the arrangement who indicate that they have designated an institute for ionizing radiation or radioactivity measurements. It is not certain that if a lab has ionizing radiation designation that they do radioactivity, radionuclide metrology, but it does not preclude it. So there's a potential of up to another 21 laboratories who could be members of CCRI Section 2. And one of the goals of CCRI this year will be to try to expand our scope and our membership. The non-CIPM MRA interests are reflected in the ICRM membership that you saw in the previous slide. But observers and guests are always invited and welcome at our meetings because they are the ones who bring to us the most clear delineation of the needs in the wider community. As a part of the survey of CCRI laboratories in what they do with mass spec activities, you can see here that there are relatively few of those 25 members who are already using mass spec or have mass spec capability that can support radionuclide metrology. And a couple are very interested in expanding the possibility. Other labs that have potential interests include a couple of National Measurement Institutes or designated institutes, both in Finland and in Slovenia, as well as other institutions in Germany and Turkey, in the UK, in the USA, and others that I haven't even heard from yet. So I think in this workshop, these 3 days, we will hear from some of them, such as the CDC and the FDA. If you've seen the tutorial on fundamentals of radionuclide metrology that is available on the website for this workshop, you will see that radionuclide metrology is fundamentally about counting events, decays per second. There's a special unit, SI-derived unit for that. That's the becquerel. You can look again at the tutorial if you feel you did not take enough notes. One thing that's very important in measuring decays per second is to make sure that you don't have decays per second coming from anything other than the source that you're measuring. One thing to bear in mind is everything is radioactive. So it's very important that we have in radionuclide metrology that we have as pristine an environment from non-relevant radioactivity as we can get. We do measure samples, anything from solids to liquids to gases. Reference materials in radionuclide metrology can have very many different origins. There are quite a few that have come out of post-Chernobyl. They all rely on previous primary measurements of a single radionuclide. This is a key component of the traceability chain in radionuclide metrology. You can see the different services that are provided in radionuclide metrology, as well as the measurement methods matrix, which we use for primary techniques to help optimize the comparisons that we do. So the status of using mass spec in radionuclide metrology at the present time is as an adjunct technique to decay counting in a variety of applications. And although the technique is not rare in academia and analytical labs, it's almost brand new in metrology labs. So there are some ongoing challenges, of course, in getting mass spec used in metrology labs. Not not least of which is the costs and the facilities to be able to do this. The potential contamination, I know from some of my chemistry colleagues that they would be reluctant to put radioactive sources in their mass specs. Measurement traceability, relating mass to activity results, how to prepare your samples, and in the radionuclide metrology, what can mass spec give us that our current techniques cannot? So our expectations from the radionuclide metrology viewpoint from this workshop are to increase our knowledge about possibly using mass spec in our metrology toolbox. What are the technical challenges and the possible solutions to those challenges in adapting mass spec in our field? What are some of the potential applications where it could be useful? And kind of increasing our connections and visibility with others interested in using mass spec to support radionuclide metrology techniques. So with that, I thank you.